So we want to contrast this idea with a situation where this doesn't quite work, okay, by multiplying probabilities, and where we should see that the sample space is always going to be our most reliable way of doing it. So what's the probability of rolling a number 4 or flipping a heads? Now, if I can actually still use my same sample space. I have two events here, and I have, in this case here, I'm just going to highlight it. I can roll a number 4. That would be represented by these two events here. And flipping heads would be indicated by this sample space here. Okay? And this, to combine this event would be, well, it's quite complicated to do some kind of, calculation of this. Whereas if we just look at the sample space, okay, the probability of heads or number 4, we can actually see, we just counted 1, 2, 3, 4, 5, 6, 7 events that are favorable. Okay, that is heads or flipping or rolling a 4 out of 12. Okay, so again, based on sample space, this is, again, I'm going to say this is from my sample space. This was very easy to do. Okay, and it's very reliable because sample space, we see exactly what's going on. Now, as a calculation, there is actually some calculation that allows us to calculate the probability of rolling a 4 or flipping a heads, but it is quite complex, quite a bit more complex than just when we have the situation of rolling a 6 and then flipping a heads. So in general, the AND form of combining probabilities is easier. The OR form is a little bit more complicated. We're not going to get into it. So in general, when we have combined events with AND, we can multiply, okay? And when we have combined events with OR, it's a little bit harder. We have to kind of combine things together. It's what we call inclusive, okay? Whereas with AND, we just exclude. So we don't include as much as we can here. What we do is we try to exclude everything except for the overlapping 4 and heads when we combine it with AND. So it is a little bit easier. Okay, and these are the ones, we're only going to work with the AND form of this, of these independent events. Okay, so the probability, this is a key idea. So probability of experiments involving 2 or more independent events. We can find the probability by multiplying the probabilities together. So multiplying the probability of success for each consecutive event. Okay, so we get rolling the dice, and then we're going to flip the coin, and then we can do something else. And these consecutive events, we can actually, as long as they're independent, we can actually multiply them to get the overall probability. And the key is we can actually use language. We can use the language of AND if they're combining it with AND.